This is the summary for Lesson 1, Number Puzzles. And in the summary, they go over several different ways to solve these puzzles. So here's a puzzle that they use as an example. Twice a number plus 4 equals 18. So what is the number? So you can start to visualize what's going on. There's a number, it gets doubled. You add 4 to it, and you end up at 18. So many different ways to solve it. One way is to just reason through it. So you have twice a number plus 4 is 18. So then twice that number is 18 minus 4. You have to subtract that 4 from the 18 to get to the number that's doubled. Once you're there, that's equal to 14. Then you just take half of that, and that's the number. So half of 14 is 7. 2 times 7 is 14, plus 4 equals 18. Another way to do this is to draw a diagram. And this is, I think, important to always do as much as you can. So a diagram, here's the number that's unknown. If you double that number and then you add 4 to it, you end up with 18 units. And so to work backwards, you take away this 4, you end up at 14 units. So 2 times that number is equal to 14. So one of those numbers is equal to 7. So x equals 7. Now I would suggest to redo this, but do it on a grid where things are in scale. This is not to scale. So 4 in this drawing is almost half of 18. So if you do it on the grid and you draw 18 units out and draw that rectangle, then you say to yourself, okay, now I have to go back 4 units to get to 14. Well, right there, you are subtracting 4. You are going through the mathematical process as you create the drawing. So that's a good idea. So you get back to 14, it's going to be to scale, and then half of that 14 will be 7, and you can actually see these numbers to scale on a grid. The last way, of course, is where we're going towards in 8th grade mathematics and into high school is writing equations and solving those equations. So they write the equation 2 times some number plus 4 equals 18. 2 times some number then equals 14. So you have to subtract that 4. So that's going to get you back to whatever this 2 times this unknown number is. That's 14. And then half of that 14 is 7. Now the authors go on to summarize these points in their writing, in which they say that reasoning and diagrams help us see the answer, think through the answer, solve number puzzles and story problems. But as they become more complex, those methods get harder. And so equations get more and more helpful. And although the math is going to get harder and the algebra is going to get harder, I would suggest to always try to include some kind of diagram or visualization or conceptualization of the problem. Don't move away from it, but begin to even embrace it more. So to make that point, I did some searching on the internet. I've known for a long time about Einstein's thought experiments. It's what separated Einstein from other scientists, in that he could actually visualize or conceptualize the physics. So I would suggest that you search, and I included some links and some QR codes below and in the PDF that's linked to this video, so you don't really have to search at all. But I'd look at some of Einstein's thought experiments and think about how that is visualizing mathematics. Ken Robinson gave a great TED Talk, February 2006, probably one of the more popular, if not the most popular TED Talk ever given, on how schools kill creativity and what we can do to infuse that creativity back into the K through 12 curriculum. These are my words. It's important to understand the symbol manipulations in algebra. Of course it is. But those manipulations can always be represented in drawings. I believe that's true. You can always come up with some kind of drawing that's a representation of those symbols. As much as possible, try to construct those drawings. And here's some final comments from the summary of what the authors wrote. They say, power of writing and solving equations. You're going to begin to see that power as we look at more complex mathematical problems. And again, of course you will. And the goal is to continue to learn the algebra, continue to learn how you manipulate those symbols, but don't move away from the visualization. So again, these are my words. Mathematics is the language of our universe, even beyond the confines of our planet. If there is life out there beyond Earth, the way that we will communicate is through mathematics. It's almost guaranteed. It's the common language of the universe. Diagrams provide a visual element to that language. So these are just 2 pages that show you everything put together, how they appear in your workbook. And so again, some further searching, I came across this quote by Dr. John Zweck, who is a professor of mathematics out of the University of Texas at Dallas. And he calls it geometric imagination. It's this quote right here. Creative mathematics at any level, and I want to emphasize, he says at any level, relies on forming pictures in your head. So continue to try to do that. And so here are a couple of links. One is to Einstein's thought experiments. Another one is to Ken Robinson's TED Talk. Another link is to John Zweck's, there's a news article about his use of 3D printing to visualize level 3 calculus, or for calculus students. And here is another page by Dr. Zweck of some printed examples, some examples of his 3D models that he constructed. So try to add a visual or a conceptual element to your learning of mathematics as you go forward.